So, hello guys, my name is Adolfo Alejandro Arenas Ramos from the University of Francisco de Paula Santander. Today we'll replace this infix and postfix method. What is this? Well, we'll see in this. So, what's this? It's a notation used to express mathematical operations. This is especially implemented in Java, and we use this to convert an expression, a mathematical expression, traditionally write by I don't know, parentheses, operators, numbers, to this form. For example, we have this operation c equals a plus b. So this method will convert this expression to this another expression, and this formula is operator 1 in this case is A, operator 2 in this case is B, and operator, okay, operator signed. And the C is declared here, okay? Why? Because the machine will read this and could be operate more easier this process that just reading this, okay? So we'll see an example. We'll test a code that receives a string with the infix structure, and then we'll review the methods that convert that into a postfix expression. Okay? Our expression is this. So, in this case, we have parentheses 2 times 4 parentheses 2 plus 2 times 3 parentheses and minus. This is an expression by operations hierarchy, and this is another operation, okay, by operations hierarchy. So we have 2 times parentheses 5 plus 1 plus 3, okay. So we'll review the terms. What are our terms? Our terms are these, our terms are these, our terms are these, our terms are these, and the complete term is this. Okay? Excellent. For this video, we'll use the online server of GDB Online Debugger. Okay? This we'll use this online tool to review and operate and see all the code. Yeah? So first, we have the main class, okay? The main class will execute all the code and will enter the expression here, and this code will return the result, okay? Well, in first time, the console class in this case doesn't matter, okay? It's just a scanner that will read our expression and will send this to the another methods operators, okay. So the important class here is this infix to postfix. Yeah, this object will operate our expression and will return well, one of the their methods will return the result, okay. So we declare infijo new infix to postfix, okay. Infix to postfix um have a property, okay. This property is called expression, okay. I'm sorry, the draw is so ugly, but this is the this is the property that will save our expression in the object in fijo, okay. So if first we say to infijo expression will be equal to the entry by the user, okay. The user will enter an expression. In our case is this expression, and infijo expression will be equals that, okay. So next, okay, pantalla layer cadena is so important in this case. Why? Because This method will return this message, will read our expression, and inside him, the method will execute the method where we'll calculate, well, calculate, no, will express the expression like postfix, okay? Initially, we have the expression in infix. So, next, we'll print the expression in fijo, okay? In fijo expression will be the original expression that we enter. And we'll declare a new variable RTA, okay, this string. Why? Because this method is a method that will calculate and will re-express our expression to the postfix, okay? This method return a string, so string RTA will be equal to the expression in postfix notation, okay? And then we'll print the result. So let's see. Okay, initially we have these, well, no, those methods. Okay, Boolean is operator, and what this method do? This method return the value true if the operator C in this case is an operator. Okay, operator. What are the operators? Plus, minus, times, and divide two. Okay, those are the operators. We won't use another operator apart of this, apart of those. Okay. Um. So we have another function. Function no is method that return a int. Int return a precedent. Okay. And precedent will evaluate another char. And this char, what is this char? This char, we'll use this chart to evaluate if the operation, well, I know, error operation is part of the first hierarchy of the operations, plus and minus, or the second hierarchy, well, the second level in the hierarchy, plus, plus now, and times, or divide 2, return 1, return 2. And if the chart is not an operator, in this case, return a less one. Okay, so and this is a property of the init of this video. Okay, string expression. The class Infix and Postfix has this property. So this is a complete class. Well, no, the complete class now is the method to transform our expression to the postfix. Okay, we don't need to send this method any param because this class have property expression, and these methods will operate with expression property. Okay, we declare a string builder result new string builder. Why? Because the terms and the operators will be set in a stack. Okay, this structure will be set in a stack. Yeah. So first we declare a for, okay, a cycle. This for will record across the expression length. Yeah. In our case is this, and will go from this to this in each iteration. Okay. So we have no we have the iterator initialized in 0 and the expression length. Why? Because our stack have a top, and the top doesn't have a value. Okay, e plus plus, the cycle is this. Excellent. So Never cycle will have a char. Why? Because the expression in every cycle will evaluate every char, every character in our expression. Okay. Now we'll proceed to evaluate and do the verification necessary to express our expression in postfix. Yeah. If the character is a letter or a digit, we'll put this character in the stack, okay? So, if is a parenthesis, and we'll give a parenthesis, and we'll put this C into the stack, okay? Until we'll found the all the parentheses, yeah? That's the functional structure of this if. Now, if the parenthesis is the last parenthesis, we'll use a while to evaluate all the stack. Okay, all the stack from the init parenthesis to the last parenthesis. And we'll put the numbers and the characters into the result. Okay, so that's the functional here. And at last we stack pop. Now else. This else evaluate if the character is an operator. So we have this validation here and this validation here and this, okay? So if if these three conditions are true, we'll put the character into the stack, okay? Into the stack. The top on the stack, and we'll return, we'll push the C character here. This structure works in this way. We have operation, I don't know, 2 plus 2, for example. If is a number, we'll put these two. Why this sequential structure? Because we'll using a for, okay? So if this two is a number, we'll put these two into the result, okay? The console result will be this, a comma. Now we evaluate this. Is letter or digit? No. It's parenthesis? No. It's another parenthesis? No. So we'll enter in this else. So see if stack is empty and if the stack is with no one value, and presidente C return the presidente in this case plus, well, we'll put this into the stack. Okay, well, not into the stack. We'll put this into the stack in this case here, and we'll put this into the result. Okay, but is this is a while, so when this condition will be not true, we put stack push. In this case, we'll put this C element in the top of the stack and we'll return this, okay? So in this case, we put this C and we evaluate this, yeah? In this case, we have another two that like we saw in the other code will be here, yeah? Now, what happened? Well, now in the result.append stack point pop, we'll delete the last element in here, we'll delete the element of the stack, and we'll put this in the result, okay? In this case, it's plus. This while will be executed every case where stack is not empty, okay? Stack have elements, and president will be, I don't know, more little or equal to the president stack peak. Okay, well, when we have this, we can note that this full recall every element, and for the parentheses the functionality is similar to here, like here, and for the characters no operators is similar too. Well, when we have the stack empty and the result with the characters inside, we'll put ever or each character that we still have in the original expression, and we'll put those characters into the result. Okay, here in this if we'll yeah, if the stack peak or the content in the stack is not a open parenthesis or a close parenthesis. Yeah. And finally, where we execute all this code, we'll return the result to string. What's the result? The result is a string where we have the result separated by commas. Yeah. Now, this is our example. Escriba una expresión en infijo. This is our expression by console. Why? Because I told you that this console is just like an scanner, okay? And this will receive our expression in a string. So this is our expression, and first print the expression in infix, okay? Print the expression have no changes because we work with the stack and the buffered reader, okay? So this is the expression, the original expression, and this is the result like string, okay? We'll see this more detail. The first values that we'll need to put in this string is this term. Why? Because we read from the right, from the left to the right, okay? So 2, 2, 2. Why there are three numbers 2? Because this parenthesis, because we need to put all the numbers first and then the operators. In this case, we operate term A, term B, operator 2 times 3, 6. In this case, is 6. Oh my god. In this case, is C. Okay? I'm sorry for my bad orthography. Now, term A, term B, this operator is no longer, is not here, and 2 plus 6, 8. Yeah, so we operate this and then we operate this. In this case is 8, and then first term, second term times 2 times 8, 17. Okay, I'm sorry, 16 is the result. So the result of this mathematical expression is 17. Okay, and this way is the same for all the expression here. Thank you.